Good morning again and welcome back. Last time we started covering the counters and timers. And if you remember, we looked at how we can build a counter, a JK flip-flop based counter. And when we look at the output of each of the JK flip-flops, Q0, Q1, Q2, we saw that the frequency of this output of the first, or if the input here was with a frequency f, then Q0 was f over 2, Q1 was f over 4, right, half the one before it, Q2 was f over 8, and so on, right? And this was apparent here. Guys, coming late, you're in, this is a lot of interruption. Okay. So when the first clock came, Ahmed Qashua, you're logging from like 10 devices. Okay, when the first clock, this input is this clock input. Okay, on a falling edge, because we had a bubble here, on a falling edge, Q0 will toggle, right? It will go to high here at this falling edge. It will go to high, stay high until the following falling edge. After the following falling edge, it will also toggle and go low. At the next falling edge of the clock, it will toggle again, go high, go low, high, and so on. And this Q0 acts as a clock for the next J flip-flop. So on the falling edge, it will toggle to a 0, go high, and stay high until the next falling edge, and so on, until everything else. So if you look at the very beginning, before a falling edge comes, Q0 was 0, 0, 0, 0, 0, 0, 0, 0. On the first falling edge, this became a 1, 0, right? 0, 0, 0, 0, 0, 0. On the falling edge, this became a 0, 1, this is a 1, then 0, 0, 0, 0, 0, 0. On the falling edge, this is a 1 here, 1, and 1, 0, 0, 0. If you follow on it, آخر شيء after 255 falling edges, the result is going to be 1, 1, 1, 1, 1, 1, 1, 1, 1. So what is this? This is a counter, right? An 8-bit counter. If you go start an 8-bit counter, I'm going to do something simpler for 4-bit, 0, 0, 0, 0. If you do a counter, from 0, 1, 2, until F at the bottom, 16. So 0, 0, 0, 1, right? Then 2 will be 0, 0, 1, 0. Then 3 will be 0, 0, 1, 1, 0, 1, 0, 0, right? 0, 1, 0, 1, 0, 1, 1, 0, and so on. So if you take this, assume this is a counter, I, انت عندك بالcode, while inside the infinite loop, you do I++, and this increments every 1 microsecond, let's say. ماشي? This means that this bit, you increment every 1 microsecond. This means you move from one state to another every 1 microsecond, right? So you were at 0, then became a 1 after 1 microsecond, then became a 0 after 1 microsecond, right? 1 microsecond. So the time here, the time is 2 microseconds of this bit 0, bit 0. This is how it's gonna oscillate. Bit 1 is half this time, right? Because see, every time had a 0, 1, 0, 1, but every 2 changes, hey, 2 zeros, 2 ones, 2 zeros, 2 ones, right? So it's gonna be double the time for this one. So for bit 1, if you connect it, if you say port B equals I and have the bits of I on port B and go take port B to an oscilloscope, to a scope, this is what you're going to see. Port B0, put it on a probe. Port B1, put it on another probe. You're going to see it for every 2 changes here is going to change once, right? Every 2 changes here is going to change once, and so on, right? So this is going to be half the frequency, and so on. So a normal counter, and this applies to timer 0 as well, that we started talking about. The very first bit changes in a rate, in a frequency, half of the frequency of the increment. Then the second bit is half of the bit before it. Then the third bit is half the one before it. So if we talk about a counter, this is a typical frequency divider system, right? So if your increment clock, incrementing I, is f, then this is f over 2, this is f over 4, this is f over 8, this is f over 16, right? You're dividing the frequency, a typical frequency divider. Okay, and I talked about this last time. And we talked about timer 0. We talked about timer 0 and how timer 0, right? Timer 0 has a clock and it overflows. You can read it anytime. You can load it with a value anytime. We saw some useful applications, and we saw how we can pick the clock source for timer 0, right? The clock source can come from the oscillator clock, directly divided by 4, with or without a prescaler, right? Prescaler means you divide the frequency or multiply the time, the delay. Or it could be an external clock that you choose which edge to increment on, a falling or a rising edge, right? Okay. And we saw that timer 0 is a memory location at the end of the day. Well, it's a register, it's a special function register. Its value is displayed at address 01 in bank 0 of the data memory. And we saw that option register has the bits that control this clock that increments timer 0, these bits, right? The option register, which is also present at address 1, but in bank 1 of the data memory. And we looked at option register, okay? And we started looking at some useful applications of timer 0. And we started with the very first application, how to make hardware generated delays. And we started talking about doing an example, hardware-based delays. And we said, let's go build on our example that we did last time, where we had the LEDs shift back and forth. And I showed this many times, and you can go see it again back in the recording running on the board. In our last application we wrote, we had port C have an LED on, right? Port C initial value was 1, right? So the first LED on port C was on. Then we shifted the LED to the left 1 time every amount of delay for 7 times, so to the 8th LED. Then we shifted it back right again, right? And this kept going back and forth forever in the infinite loop. However, we had an interrupt enabled. We had an external interrupt enabled here, external interrupt enabled, and tied to the external interrupt pin, which is port B bit 0. Whenever this happens, a falling edge happens, the interrupt service routine is executed. And in this case, we wrote the interrupt service routine to blink port B 10 times or toggle it 10 times, which will appear in terms of 5 times on, 5 times off. And we said, remember this delay that, well, before going to the delay, I want to ask a question. Assume you came and you don't know about this shift operator. You don't know about this shift operator, okay? But you want to do the shift left, or you don't know about this shift right operator, and you want to do the shift right. You don't know about it, or it's not available, or whatever. Broken, you're not allowed to do it. How would you do this? Keep this program doing the same thing, using something else other than this shift operator?
تقدر تضرب باثنين.
Thank you, Saleh. So what is shifting left? Shifting left is a multiplication, right? Yani, shifting left is a multiplication. And shifting right?
Division.
Is a division. So you're aware of these things, right? Sometimes, I don't, right? So a number 1, 0, 0, 0, if you shift it left, it will become 0, 1, 0, 0, right? This is a 1, this is a 2. If you shift it another time left, it will become 0, 0, 1, 0. This is a 4. Another time 0, 0, 0, 1. This is an 8. So every time you shift left, you multiply it by 2, right? And every time you shift right, an 8, shift it right, it's a 4, shift it right, it's a 2. And this is actually something handy, right? Even in math operations, yani, if I ask you to write some code to solve for y that equals 2x plus 1, and I say that you are very strict on time and you're running on a resource constrained system and you need to complete this operation as fast as possible, what's better? To do a multiplication operation? Well, in our microcontroller, this one, we don't have a multiplication instruction, so it's going to be converted. This could be converted to shifts or to multiple repetitive additions, right? So a shift will be faster. So you shift it even number of times, then you, if this was 3x, you shift it once and then add x to itself, right? If it was 5, you shift it twice, that's 4x, then you add another x, and so on. طيب. I'm just throwing ideas here real quick. And these are basic programming stuff. طيب. So when we did this, we used a delay between every shift and another, right? And this delay was just wasting time. And now we saw that we can use timer 0 to make hardware-based delays. Well, this is what we read in the slide, at least. How would we do that? Let's go just think about it loud here, okay? And see how we're gonna do it. We saw that timer 0, increments every amount of time, right? Based on the oscillator clock, if we want to build on our oscillator clock, divided by 4, and we can play with the timing, with the frequency that through this prescaler, right? And we can choose and pick or define when the timer is gonna increment, right? And we know that the timer, when it reaches its maximum 8 ones, which is 255, and receives another clock, it will overflow. And in this case, the timer 0 interrupt flag will raise. And if we enable the timer 0 overflow interrupt, it will cause an interrupt and take us to the interrupt service routine. So we can choose when an interrupt happens. طيب. ماشي. So based on this, we're gonna go do some math and see how to play with the time to make timer 0 overflow after a certain amount of time. That will help us. طيب. So to compute the time, there's a prescaler we're going to look at. I copied these registers. To yeah, I copied these registers. Let me also copy this one to here. ماشي. So if we pick the oscillator frequency I have on my microcontroller is an 8 megahertz clock, right? After dividing it by 4, this will be here 2 megahertz. طيب. So if we do this bit needs to be set to 0 to be able to pick this oscillator frequency divided by 4. Then 2 megahertz, if we take it as is without a prescaler, then this is 1/2, which is 0.5 microsecond. Then this timer 0 will increment every 0.5 microsecond, which means after 256 counts to overflow, then that's 128 microsecond, right? 128 microsecond is too fast to get an interrupt every 128 microsecond. So we need to slow it down because I want the shift to happen every half a second. Okay, so we will need to use this prescaler. So this PSA, we're going to make it a 0 to take this reading. Now, what about the prescaler? Let's go slow it down as much as we can. The maximum prescaler we can use is this one, 1 to 256. So we need to set these 3 bits to 1s. These 3 bits, 1, 1, 1. That will give us a 256 prescaler, right? Prescaler. What does this mean? Let's do the math over here. So if the oscillator frequency equals 8 megahertz, right, over 4 will be 2 megahertz, right? So without a prescaler, timer 0 will increment every, how much? Every this frequency, right? 1/2 megahertz, which equals 0.5 microseconds, right? It will overflow, timer 0 will overflow when? Every 256 counts, right? يعني 256 counts times هذه per count, right? Every count will take 0.5 microseconds. Then this will equal 128 microsecond to overflow. And this is too slow. Now, this was without a prescaler. طيب, without a prescaler. If we use with a 256 prescaler, then we're slowing the whole thing 256 times, right? So the oscillator frequency over 4, right, is if assuming this was 8 megahertz, will be 2 megahertz. Then with the prescaler, you're dividing this by 256, right? Or you're multiplying the time by 256. So time, right? We get from this clock is 0.5 microseconds without prescaler. Time with 256 prescaler, this will give us 256 times 0.5 microseconds, right? Equals 128 microseconds. Now this 128 microsecond is what? Per increment. بالأول here without a prescaler it was 0.5 microsecond per increment, but we count 256 times. To overflow it was 128. Now every count here, if we use a prescaler, will take 125 microseconds. طيب, time to overflow. Time to overflow with 256 prescaler will be this time 128 microseconds ضرب times 256, right? And this equals to what? Real quick. 128 microseconds. 128 microseconds times 256 counts, right? This is 32.7 or around 32.7 or 0.8 milliseconds. So 32 point something, we can ignore this part for now, milliseconds. ماشي? So our timer 0 will overflow every 32 milliseconds, and this is the slowest we can do, صح? Because we made it count the full range from 0 to 255, then overflow back again. So we counted full range, and we used the slowest clock. We used the maximum prescaler, right? We use this maximum prescaler, so the slowest possible clock. If we want to make this timer overflow slower, if we want to slow this more, then the only thing we can do by hardware is just changing this oscillator frequency, nothing else. Or we can overcome it. Our goal now is to generate a 500 milliseconds. 500 milliseconds. We have two options: to change the oscillator frequency or do something by software. بمعنى create a flag, create a software flag that call it counter. You increment every 32 milliseconds, right? Increment it every 32 milliseconds. Then 500 milliseconds will be reached after how many after how many counts? When the counter reaches what? 500 divided by 32, right? 500 divided by 32 milliseconds, almost 15. طيب, almost 15. So if we increment a counter, increment it every 32 milliseconds, it will become, 500 milliseconds will elapse when the counter value becomes a 15. صح? So this is how we can do it. We can do an interrupt service routine that increments a software counter every 32 milliseconds, and we check the value. When it is 15, we do the shift. If it's not 15 yet, we don't do the shift. And when we do a shift, we reset this back to 0 again, to count 15 again. تمام? Let's write the program to do this. Oh man, time is moving really fast. So to do this, first we need to enable timer 0 interrupt, right? We already had the external interrupt timer there, right? So we already had a configuration for the intcon. We don't want to change it, okay? The only thing we want to do to enable the timer 0 interrupt, which is this bit, right? To make this bit a 1, to make it a 1, to enable the timer 0, we can do an OR with 0, 0, 1, 0, 0, 0, 0, 0, right? So we enable the timer 0. So we need to enable مش the timer 0, the timer 0 interrupt. This is first thing we want to do. Then we want timer 0 to start counting from 0, the full range, to 255. We want to make it a 0, initialize it with a 0, initialize it with a 0. بعدين when we write the interrupt, okay, timer 0, we want to define the time, how fast it increments. We said we want to use the maximum prescaler. So the option register has to be 1, 1, 1, and we want to use the prescaler, right, for timer 0. So this bit is going to be 0. And the select edge here, the select edge, we don't care about it. So it can be 0. The clock select needs to be 0. So here, select edge can be 0, this can be 0. Interrupt, external interrupt edge, we didn't set it last time. It default is 0. It was on a falling, or we can just keep it a 0. And this one, enable it or disable it. Let it be disabled. So a 1. ماشي? So the option register needs to be set to this value, 8, 7, right? And the intcon register needs to be ORed with a 2, 0, right? So if we go back to our code, and I copied it last time into a new project, I think I did, and we called it hardware demo 7. Is it 7? Yeah, 7. ماشي. And intcon here, when we enable the global interrupt enable and the external interrupt enable, we can just change the value here, but let's learn another way without touching it. Intcon, right? I want to enable equals intcon ORed with 0x to 0, right? So enable well, set timer 0 interrupt enable, right? And those enabled, the ones before, will stay enabled. طيب, timer 0, we enable the timer. Timer 0 needs to be initialized to 0, right? The option register, and I'm doing these initializations in the main before the infinite loop. The option register needs to be set to what? What was the value? 87 hex. 87 hex, right? And here what we did is we used the oscillator frequency divided by 4 with a 256 prescaler, right? This will cause an increment for timer 0 every 128 microseconds, right? And and overflow every 128 microseconds times 256 every 32.7 milliseconds, right? This is the setting. So we enable the interrupt, we decided the speed, and we initialized timer 0 with a 0. I think we should enable it. We should enable it after setting the timing and initializing. So we make sure it starts from 0. Tamam? Here. So now we can go write our interrupt service routine. Well, we already have an interrupt, right? اللي هو external interrupt. This is what we want to do when an external interrupt happens. صح? But when an overflow interrupt happens, we want to do something else. So now it's a multi-interrupt thing, okay? It's a multi-interrupt thing. So we need to check which flag brings us to this interrupt service routine. So we say if what? If int con ANDed with, we mask all other bits and we check for the external interrupt flag, which is what? External interrupt flag, this one, right? Everything's zeros. We AND everything zeros except this one, a 2, right? So with the 0x02, then, okay, sorry, and let me move it up because it's a definition. If this is true, I want to do all this. This is for the external interrupt, right? Okay, guys, what I'm going to continue writing this code. I'll upload it. The recording will be there. If you have a class and you have to leave at 11:10, we still have 7 minutes. I think we finish. But if we don't, you can leave. It's okay. طيب. Now, if we get here because of the timer 0 overflow flag, so we need to check what is the flag. Timer 0 overflow flag. This is the bit. If this is 1, and everything we OR it with a 0, we ended with a 0, so 1 0 0, a 4 hex. A 4 hex. So if int con is ANDed, we mask everything with 0x04 hex, then we're here because of what? Of a timer 0 overflow, right? Timer 0 overflow. And this will, every 32 milliseconds, 0.7. So we're gonna get here every 32 milliseconds. طيب. I don't want to do a shift every 32 milliseconds. I want to do the shift every half a second, يعني 500 milliseconds, right? So we can do this. We can define a software counter زي ما حكينا قبل شوي. A software counter. وين حكينا هذا الحكي؟ A software counter that we increment it every 32 milliseconds. When it becomes a 15, then our 500 milliseconds have elapsed, right? So if we do, let's say, a delay counter plus plus, يعني طبعا هذا, this one we need to define it, right? And it has to count to maximum قديش?
15.
15, right? So يعني an unsigned character will do it, right? Because it's unsigned character delay counter initially 0. تمام. Initially 0. Every time we're here, we increment it. When its value, when its value is equal to 15, right? We want to do something now. Yani when it's 15, this is after 500 milliseconds, and we did the math. What do we want to do? Okay, we want to give an indication to the main loop that, oh, you're clear to shift. You're clear to shift. Let's do a flag. let's do something called a delay flag, and make it equal to 1. And this delay flag, let's go define it as well up there. And it's either, because it's a flag, it's either a 0 or a 1. So an unsigned character will do initial value 0, delay flag. Tamam? We raise the flag. And before we leave the interrupt here, before we read the interrupt, we need to clear the external, the overflow interrupt flag. How do we do that? How do we clear the timer overflow flag? It's in the intcon here, صح? Intcon, timer 0 interrupt flag. This one we want to clear it. We want to make it a 0. So we can OR everything with ones, or everything with ones, except this one a 0. صح?
And صح إن شاء الله.
يعني 0x.
Yeah, so we can add
0x FD.
F B صح? FB, right? So we say intcon equals intcon ended with 0x FB. It was right, and this clears the overflow interrupt flag, right? Good, we're done here. Going back to the main loop, I want to remove this delay. هذا الديلي اللي كتبناه المرة الماضية, this one that we waste time. I'm gonna comment it. Okay, what do we want to do instead of it? We want to say keep waiting for that interrupt flag. So while that interrupt flag, delay flag, while that delay flag is still not 1, يعني still equals to 0, لأنه initial value تاعها 0, right? Just get stuck here. See, I'm putting a semicolon. يعني while this is true, don't do anything. Just stay stuck here. If it's true, when the flag is 1, it's not 0 again, right? So the condition is false, it's gonna move. We come here, now we can reset the flag, right? Yani bring it back to 0 because it became a 1. How did it become a 1? It became a 1 here inside the interrupt service routine. طيب, after 500 milliseconds. The delay counter, by the way, the delay counter, هذا delay counter لما يصير 50 when it's 500, what do? We clear it as well, صح? ليش؟ عشان يرجع يعد نصير counting over again. We need to clear it. Otherwise it will become 16 next time, 17, صح؟ طيب. So what we did here, what we did here in the shift for the delay, we say wait for the flag to become a 1. When it becomes a 1, while it's 0, keep waiting. When it becomes 1, we move. When we move, it's a 1, we bring it back to 0. Sorry, we bring it back to 0. Delay flag. خلاص صار, this is our delay. So we're gonna get stuck here in this while for 500 milliseconds because the flag is not gonna become a 1 except after 15 counts, which is 500 milliseconds. Got it, guys? And here I'm gonna just replace it. This is exactly 500 milliseconds. خلاص, if we run our code, I'm gonna build. I'm turning on, and this is the last thing. Build and program. And we have what we did here. We have multiple interrupts. Did it build? Yes. Okay. Program. Okay, done. It's done, right? I'm gonna just stop sharing my screen and show you the other camera. See? You see the lights here?
Yes.
Exactly 500 milliseconds. This is really exact time. يعني with شوية microsecond shift. And this is an interrupt based. And we still have the external interrupt. If I push, put a falling edge on the external interrupt, the shift will stop, and we're gonna go blink 10 times for it to be 5 on, 5 off. Then we go back to the shift. Cool? Cool. Tamam. Class is over, but let me tell you, yani you can leave. Let me ask you a question. What if I ask you to write a function, a delay function? Yani let me go to my code here. Yani instead of doing this and having this delay only for 500 milliseconds, excuse me, what if I ask you to write a function called my millisecond delay that takes an interrupt, an integer, and you can pass it any and if you say my MS delay 1, it will do 1 millisecond delay, 500 millisecond delay, 5,000 millisecond delay, up to 65,000, right? يعني 6 seconds and a half. Can you do that?
Yes.
تعمل الماث اللي عملناه قبل شوي جوا الفانكشن.
Exactly. And this is what I did for you offline, okay? And let me show it to you. This is what I did offline, because we don't have a lot of time to do it again in class. So I did it offline here, the same example. Oh my God, what am I doing? Cancel. Let me close everything. Do you want to save? No. Well, the last save thing is what we built. Okay. So I wrote this delay function. So you're not allowed to use the delay functions built in the libraries, okay? You need to be able to build it on your own. We're not spending all this time on the interrupts and timers and not use it. Okay, this is the exact same function, the exact same program we did, the shift, see, the shift. But I wrote a function called my MS delay, okay, that looks like this. مش هذا my delay here. Here, I did a delay counter. I set the option register. I made timer 0 start counting from 247. ليش؟ 247 يعني overflow after 8 counts. Okay? 8 counts, 128 times 8 is 1 millisecond. ماشي? So I want timer 0 to overflow every 1 millisecond. So I cannot make it count from 0. I did the math to see, okay, how many times does it need to count to get to 100 to 1000 I know that it increments every 128 microseconds. صح؟ طيب. How many times does it need to count for a 1 millisecond? 1 millisecond is 1000 microseconds. Divided by 128, 1000 microseconds, divided by 128 microseconds, that is almost 8 counts. طيب, 8 counts, so 255 minus 8 counts is 247. So if this timer 0 starts counting from 247 after 8 counts, it will overflow and I get an interrupt exactly after 1 millisecond. تمام? Here I enable the timer 0 and I pass an integer d, which هو my delay, one millisecond, 10 millisecond, and say, if my delay counter is still under this, keep waiting for this, my delay counter to increment. Then I disable the interrupt timer 0 after the delay. Where does this delay counter increment? I made it increment inside the, here, inside the timer 0 overflow interrupt. Okay, so this increments every 1 millisecond. صح? And I passed مثلا the 500 millisecond. I keep waiting for it until it gets to 500. That's my delay. But every time I enter the interrupt service routine, I reset timer 0 overflowed, right? Overflowed means it became a 0. But I want it to become a 247, to start counting 8 times. So I want it to overflow every 8 times. So every time I get into the interrupt, I reinitialize it to 247. Everything is the same, okay? So here, all what I do is just give it how much delay I want, 500, 300, 200, 100, إلى آخره. I'll upload this code for you as well. ماشي? It's running, I tried it and it's running. Thank you very much. You can stay for questions and I'll upload everything to the learning management system and see you Thursday. Thank you very much.